So what is electrochemistry? Electrochemistry and then electro, supply of electric. That is called electrochemistry. Alva? See, whatever you take it in simple. Don't take in complex. Hashtag. So electrochemistry. Electro, you know electro, supply of some electric power, right? So that study of that is called electrochemistry. So electrochemistry, this one, two types. In that, one is electrolytic conductance. Electrolytic conductance. Okay, one more is electrochemical cell. Electrochemical cell. Okay, so in this you will have only numerical part. Most probably they'll ask only numerical part in this. Here they'll ask concept and as well as numerical part. Asking question papers. Okay, then let me take electrochemical cell. What is electrochemical cell? And in electrochemical cell, they just see the chemical energy. Okay, so chemical energy and you know if there is any reaction that has to come for end, correct? Any reaction, whatever you start, that has to come to an end. That is what A gives you B. So here, chemical energy. What is the main question is, what is chemical energy? Okay, to understand that, this example, and here, chemical energy of a reaction is known as Gibbs free energy. Chemical energy is also known as Gibbs free energy. The change what is happening here, it's called Gibbs free energy. That is your delta G naught. Okay. This much if you understand in this, it's enough. Okay, then next. Electrochemical cell. Okay, in electrochemical cell, you have two types. One is what? Galvanic cell and electrolytic cell. Okay, galvanic cell and electrolytic cell. In this, probably they would have asked you the charges. What is the charge in that? Okay. So in galvanic cell, okay, you have to remember that it is spontaneous reaction. Okay, galvanic cell is a spontaneous reaction, whereas in electrolytic cell, okay, this is your non-spontaneous reaction. Okay, so spontaneous reaction which is happening itself. Okay, which some reactions which is happening on its own is called spontaneous reaction. This is taking somebody's help and the reaction is happening. That is called non-spontaneous reaction. Okay, yes. Then you have to remember is 3 point. I'll mark just that 3 point. Spontaneous reaction, non-spontaneous reaction. Delta G, Gibbs free energy, should be negative. Okay, here delta G is positive. Okay, then conversion. Here chemical energy is converted to electrical energy. Okay, whereas here electrical energy to chemical energy. If you remember this 3 point in this two difference, it's enough to solve the problem. Then you have to understand this better. Electrolytic cell, it is having some electrode, right? So there you have what? Which electrode? One is anode, one is cathode. So two electrodes will be there, right? Obviously two electrodes will be there, should maintain the neutrality. So there, this two electrodes is connected to some battery. Plus and minus. Always plus should be higher, minus should be small. That is your battery. Now, the current is flowing from this side. Correct. When current is flowing, tell me which is anode and which is cathode in this. Which is cathode and which is anode? Positive sign is what? Anode. Negative side is? To find out the difference. You know, cation, cat, positive. So cathode is ODE, negative. Okay, the similar way, anion, we know anion is negative, and ion. So here ODE means opposite to this, that is positive. Okay, remember that. So this is your anode, this is your cathode. Okay, done. So this 2 electrons has been dipped in the NaCl solution. NaCl. So Na plus, Cl minus. So Na goes here, Cl is here. Okay, done. Okay. So idrali you have to understand mainly 4. What is that? Anode. Where does it take place exactly? Then cathode. Then oxidation. Then reduction. If you remember this is enough. Okay. So what is that? Anode. Anode should always be positive. We know that anode is always been positive. Correct? Yes, we know that. Then, where oxidation takes place? In anode, only in the anode side, oxidation takes place. This you have to remember. Okay? Then, so for example, in this NaCl, oxidation ante heladre enu? Cl minus plus 2 electron gives you Cl2, correct? Half Cl2. ಅಲ್ವಾ ಅಲ್ಲ ಇದು ಆಕ್ಸಿಡೇಷನ್ ಅಲ್ಲ 2 ಎಲೆಕ್ಟ್ರಾನ್ ಈ ಕಡೆ ಬಂತಂದ್ರೆ ಇದು ರಿಡಕ್ಷನ್ ಸೊ anode should always have positive and there only the oxidation takes place. Oxidation andre it should become 2, so therefore Cl minus gives rise to half Cl2 plus it's giving you 1 electron out. This is your oxidation. Okay, understood this one. Then in case of cathode, opposite to this, cathode is what? Always it should have negative charge, right? Idralli enagtide Na is taking that 2 electron to nullify as Na plus or Na solid. Na plus iradu electron jote mix agi Na solid agtade. Okay. So this 2 electron alla, it is 1 electron. Because why I took 2? I thought it was Na2. Cl2. That is there no 2 NaCl. This depending upon molarity. I took that too. Leave this. Okay. If I take only Na and Cl, this is a reaction. Okay. Done. So anode and cathode done. Next you have third one is oxidation. What is oxidation? Addition of oxygen, removal of hydrogen, or loss of electrons. Okay, it is losing some electrons. So it is losing this electron. Which is it? Oxidation, right? It is losing its electron. This one. Allinda idu aache kalstidana losing. So that is called oxidation. Okay. Then reduction is what? Opposite to this. Addition of hydrogen, removal of oxygen, loss and gaining of electron. This is a reduction. So from here, idu aache kodtu adanna tagombandu inga hakontidini. Adanna gain. Okay, done. So you have to remember is the electrode where oxidation happens is known as anode. 1. The electrode where reduction happens is known as cathode. 2nd. 3rd, electrodes are all the metallic plates. Whatever the electrodes has been there, this electrodes, it's always a metallic plate. This you have to remember. It's always a metallic plate. Okay. Then we always assume aqueous solution. Then free electrons cannot remain in the solution. They are present on the surface of the electrode. So free electrons, whatever it has been there, they depend only on the surface of the electrode here. Whatever the free electrons are there, they'll come and accumulate on the surface like this. Then the redox changes, the reduction whatever it is happening takes place at the surface of the electrode only. This main points in this if you remember enough. Okay, done. Then galvanic cell. So that was electrochemical cell, right? Electrolytic cell. Now we are studying about galvanic cell. Okay, galvanic cell, we know that, right? So two solutions will be there. In between that, salt bridge will be connected. Correct? So you will have electrode and electrode. Correct? So this electrode will be connected to positive and negative. This we know, right? So here we have ZnSO4 solution. Here CuSO4 solution. This is your cathode. Cathode means positive. Allah. So positive means cation is positive. So this is your anode. This is your cathode. Alright? Now tell me, ZnSO4 is there and CuSO4 is there. So depending upon this Cu and this Zn, okay, which is happening mainly in this oxidation and reduction, yav happened. Okay, you have to give the representation of the equation. Okay. So ZnSO4 means what? Zn plus 2 plus plus SO4 2 minus. CuSO4 means Cu2 plus SO4 2 minus. Right? So this is what it is there. So this electrode is having Zn plus 2. Correct? This is having Cu2 plus. Alva? If you remember this, it's enough. So cathode ಏನಾಗ್ತಿದೆ, anode ಏನಾಗ್ತಿದೆ, ಯಾವ ions, ಯಾವ ions. Okay? So that galvanic cell is also called as voltaic cell or Daniel cell. Okay? So galvanic cell is also called as what? Voltaic cell or Daniel cell. Illi representation ಮಾಡಬೇಕೀಗ anode. In anode what was there? Zn, right? So Zn ಇದ್ದಿದ್ದು ಏನು ಕೊಡ್ತಿದೆ, ಏನು ಹಾಕ್ತಿದೆ Zn anode side ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? No, in anode always takes some oxidation, right? Whereas cathode is always reduction. If it is oxidation, it means to say what? Loss of electron, right? Loss of electron anta helidre kodtiradu, right? So oxidation gives you, here it is what? Zn 2 plus how many electron? 2 electron. So this is your loss of electron. Okay, then in cathode what was there? Cu, right? So Cu 2 plus is accepting this electron ಕೊಟ್ಟಿರೋದು. So ಏನಾಗ್ತಿದೆ ಅದು? Okay, understood? So that's all. So wherever you write this, you write S and this is S, solid. Okay, done? So here it is gain of electron. Electrochemistry is dry subject, so I am going very slow. Okay. Here, what you have to remember is electron flow from anode to cathode. First point. Okay, that salt bridge formula you have, right? So the electrons, whatever it is there, they are flowing from anode to cathode. Okay, anode in the only cathode ಹೋಗ್ತಿರೋದು. Then flow of current would be from cathode to anode. So flow of current. Flow of current would be from cathode to anode. Okay, then this one. This if you remember enough. Zn2 plus is always greater than SO4. 2 minus. Okay, then Cu2 plus is always lesser than SO4. 2 minus. Okay, this if you remember enough. Then salt bridge. So that salt bridge, it acts as what? So salt bridge, it brings the electrical neutrality in between them. So anode and cathode madhyadalli electrical neutrality agoskoskara salt bridge. So mainly one question will be on salt bridge. Both for CET and salt bridge mele what it acts as. That question will be pakka. Okay. Then what it is made up of. So salt bridge is made up of what? Salt bridge is made up of KCl and agar-agar. This also there is a chance of asking. Okay, then Difference between the galvanic cell and electrolytic cell. Now this is over. So you studied electrolytic cell and you studied galvanic cell, right? So what mainly you found the difference? Only the charges. Correct? Only the charges you found. So what was in galvanic cell? Electrolytic cell and galvanic cell. Only the charge battery will be different. What is anode and what is cathode? I didn't tell you this, right? I'm sorry. Okay. In electrolytic cell, anode will be always negatively charged. And obviously this is positive. Okay. Opposite to this. Positive, negative. This if you remember enough. Okay, this is the difference between the electrolytic. So, whenever they give you the formula, solving the problem, you have to remember this, galvanic cell or electrolytic cell. Which charge is happening where?
In electrolytic cell it will not.
In electrolytic cell. Yes. The syllabus please. Okay? Just I didn't tell. I'm sorry for that. Okay? This you remember. This is very important. And with electrolytic and this one, galvanic. So it's there. So electrolytic, galvanic, main part, half part, mudita. Okay. Then you have cell notation. So cell notation will get 2-3 marks it will be there in competitive. Okay. Right? Okay. So cell notation. How do you find the cell notation? I have told, right? That one, salt bridge. This is your salt bridge. Here you had ZnSO4. Here you have CuSO4. Okay. So now I am taking 1 mole of ZnSO4 and here I am taking 0.1 molar of CuSO4. Okay. And this electrode, whatever it is dipped here, Zn and Cu, it is having charge battery, like it is supplied. Okay. So now we know zinc is anode. Zinc is anode. Correct. Always remember, how to remember is, when you take, always this side it should be anode, this side it should be cathode. Always. No change. Only the sign changes. Okay, depending upon the electrolytic cell and the galvanic cell, only the sign changes, but always you have to remember cathode is right side and anode is left side. You can't bring this anode here or this cathode there. No, it can't be done. Okay? This is understood, right? So anode ಏನು ಆಗ್ತಿದೆ, cathode ಏನು ಆಗುತ್ತೆ. So copper is cathode. So you know what happens in anode and what happens in cathode. Oxidation and reduction. Okay. Now, how do you represent this? There is a main question for 2 marks. How do you represent? So they give you this diagram and ask you how do you represent the cell. Okay. So usually we know salt bridge should be represented as double bond, double this one. So this salt bridge you have represented here. And always cathode part is this side, anode part is this side. Right? Correct. So in cathode part, okay, what it should happen? Cu2 plus. Why Cu2 plus? Because in cathode what is happening? Oxidation or reduction? So that is what? Cu2 plus 2 electron give rise to Cu. Correct? Here Zn give rise to Zn 2 plus 2 electron. Okay. Now cathode is what? Main reactant you have taken, Cu2 plus. That should be here. Okay. Understood? Then after Cu2, what it is giving you? Cus. That should be written here. So this is done. This is your cathode representation. And there is a question. They'll not give you anything here. Only the salt bridge. And they'll give you this. Represent the cell notation for this given diagram. How do you represent? Only so much. Okay? Only so much. If they are not giving this, you don't want to write. But salt bridge should be there. This is your cathode cell representation. Okay, then if they're not giving you cathode and they're asking you anode representation, it means to say here, what do you get here? Elaine Barutte. Cu2 plus, right? Now tell me.
Zn.
Yes, Zn. Zn2 plus. Got it? Now you are clear, right? Now, if they ask you, if that CuSO4 part is not given and only this part is given, represent the chemical equation for this and the Q3, this you have to not write. Okay, only so much you have to write. Okay, understood? So, there is a chance of asking cathode representation or anode representation. Okay, cathode representation or anode representation or complete cell notation for the given cell. Complete cell notation means both the thing will be given. So therefore you write Cu2 plus Cu. Yes. Okay, now Cu2 plus. Here you have to write the molarity. If they are given the molarity, pakka you have to write the molarity. If you are not writing, you lose some mark. It should be written. Okay, clear with cell notation, cell representation of cathode electrode and cell representation of anode electrode. In this, there is a 4 question. I told you that 4 question also. Okay. Then, you have gas ion half cell. So after this, gas ion half cell means, along with this, some electrode will be there. Okay, some electrode which is inert. You can take PT, H and C. Either of these 3, among these 3, there will be given. Avag representation of cell ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಮೇನ್ ಆಗಿ ಏನು ಕೊಟ್ಟಿರ್ತಾರೆ ಅದನ್ನ ಈ ಕಡೆ ಬರಬೇಕು near the anode cell. Okay, this I'll tell you. See, gas ion half cell. Okay, that cell is represented as this. Here hydrogen gas is coming. It is intaken. Okay, and this is the electrode. This has been dipped in the 0.1 molar of H plus ions. Okay, then an electrode is being there. Salt which is there. This is your salt bridge. Okay, this is your 0.1 molar H plus ion, and here you have some electrode which has been having mercury or platinum or copper or carbon. Okay, so here they have taken platinum. So platinum is represented as Pt. This is your electrode which is taken over here. Okay, now when platinum electrode is there, they are asking you to represent the half cell of anode, right? Half cell of what is this? Positive alva anode. Why? How did you get this as anode? I don't know whether it is anode or whether it is a cathode, right? Because they have given only one cell and salt which is given. But I don't know whether it is a half cell. I don't know. What is an anode? How do you get that? Because they have taken here it is what? H plus. H plus what? To get H plus, what do you have to do? I have to get H plus here. What have to take here? H. So which H? H is stable? H is stable? No. Atom should be combined with another atom. So it should have molecule H2. So this H2 I have to get H plus. I have to balance this. Half H2. So half H2 on. What do you get this H plus and it is releasing some electron? Okay, what is that? What process is this? Oxidation or reduction? Oxidation. Okay, oxidation ಅಂದ್ರೆ loss of electrons. ಕೊಡ್ತಿರೋದು ಯಾರಿಗೋ ಕೊಡ್ತಿರೋದು ಇದು ಏನು ಮಾಡ್ತೀರಿ ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋದನ್ನ ಆಕ್ಸಿಡೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. So it is oxidation. So oxidation always takes place in which electrode? Cathode or anode? Anode. Now this is anode, correct? Now they are asking me to represent the cell notation for this diagram. Okay, how do you represent? We know. Okay, salt bridge is there, right? Salt bridge is there. And anode should be always which side?
Left.
This side, right? Yes. What should I have get here?
Half H2.
Half H2
H plus.
H plus. Correct? ಈಗ ಇಲ್ಲಿ ಯಾವ electrode use ಮಾಡಿದ್ದಾರೆ? Platinum. Why can't I write this platinum over here? Why can't I write this platinum over this side, crossing the salt bridge?
Because that side is
Cathode. So I'm not writing here. They'll give you the option like this. Okay, they'll give you like this option. One is like this. One. Second thing, they'll not give you this salt bridge. Okay, they're not giving you that salt bridge. One option is they'll give you PT, H2, H plus, salt bridge. Okay, this is first option. Second option is H plus, H2, salt bridge, platinum. Is this correct? No. As soon as you see in the similar way, I'll tell you, wait. Okay. H2, H plus, okay, salt bridge, platinum. These two options are similar. Why? Because platinum is this side. Okay. Then, as soon as you see this and you see something is there, you tick something. So, answer would be this as answer. You would have ticked this. So, you have to be careful. Okay. Then, one more is fourth option. Half H2, H plus, salt bridge. Here you have platinum, which is correct. This is correct. So based on this, you have series of questions. Okay, even in the cathode. So they would have given some salt bridge, and depending upon the solution. Okay, here it is I took H plus. They might have given you CuSO4. Okay, so CuSO4. Now first you have to write the equation. What equation is giving that? What it is giving. So Cu is accepting, right? It is accepting the electron. So Cu plus 2 electron gives you Cu2 plus. If it is accepting, it is reduction, correct? When it is reduction, obviously reduction takes place in cathode. This all you have to remember when these options are coming. Okay, probable questions are based on this main target. Okay, na? Then. And always remember, you have to write the mole what they had given. They will be given. Okay? Understood? Yes. Then you have redox half cell. Okay? Redox half cell, this is a theory part. If oxidized and the reduced part, both are ions, it is called redox half cell. Okay? And then you know, if the oxidized and the reduced part, so oxidized part to reduced part, both if it is there. It means to say what? Can I take Na plus Cl minus give rise to NaCl? Now tell me what this is happening and what this is happening.
Oxidation Cl, reduction reduction.
Okay, that is what they are giving. So idana navu complete agi redox reactions anta ಹೇಳ್ತೀವಿ. Okay. So then, to represent the redox half cell, okay, we need to use inert electrodes. Inert electrodes ಹೇಳಿದ್ದೇನೆ, right? Which is that platinum, palladium, even the graphene electrode is also used. And rarely there is a question, they have used this C also. This option, it is in question, I'll tell you that. Okay, so carbon, rarely this carbon is also given in the options. Options are ಕೊಟ್ಟಿರ್ತಾರೆ. Okay. We know these are inert electrodes. We don't know carbon is an inert electrode, right? Yes. So then you will take some other option and you'll go. So this, wherever this is there, that is correct option. Okay, I'll tell you what question is arising there. Okay. Why they are inert? They do not react with the electrode. So they are inert. They are not reacting with the electrode. So they are inert. Okay, done? Okay, next you have oxidation potential. Okay, oxidation potential is represented as EOP. Okay, EOP. So, there would have been a question like, if EOP is this, anta. So, then you have to remember it is oxidation potential. Okay. Okay, so in oxidation potential, elements with high tendency to losing electron are showing oxidation. What do you mean by oxidation potential? Oxidation and loss of electron. Adine potential and it is having high tendency to lose it. Correct? So high tendency to losing electron or it is showing oxidation is called oxidation potential, which has been represented as EOP. Okay, then you have the similar way you have reduction potential. So reduction potential and the it is ERP. Okay, how you are linking this both? How do you link ERP? This is a link. ERP minus EOP gives you the redox potential. Okay. That is oxidation potential, down one is reduction potential, overall both gives you the redox potential. There is a difference between oxidation, reduction and redox. Okay, beta. Sorry? Rest Got it, Anna? Then you have oxidizing agent and reducing agent, main two agents. Okay, so oxidizing agent it itself gets reduced and oxidizes to others. You know this one. Then it has high reduction potential. Okay, in oxidizing agent, third one, oxidizing agent, you know, itself oxidizes and it reduces to others, right? Second part you have to remember is it is having high reduction potential. High reduction potential. Mainly based on this or this, there is one reduction potential made. Whether it is undergoing oxidation or reduction. Okay. Then in reducing agent, what does it happen? Itself reduces and oxidizes to others. So it will give you the opposite to this. If this is high reduction potential, here it is oxidation potential. High oxidation potential. So if you remember this two, it's enough. Okay. Then, so next you have EMF of cell, right? EMF of cell is based on 4 parts. What are the 4 parts? If you remember, it's enough. Okay? I'll stop with this topic, okay? So, EMF of cell, it depends upon 4 parts. Nature of chemical reaction. Okay? Second thing, concentration of reactants and products. What happened? I'm a bit tired, I can't stand it. Pressure of gas. Fourth one, temperature. Okay. So, EMF of cell, if they are asking to write the EMF of cell, it mainly depends upon these 4 parts. Okay. One is nature of chemical reaction. Second, concentration of reactants and products. Third, pressure of gases. And fourth, it is temperature. Okay. That's all you have to remember here. Then you have SATP conditions. What is this SATP condition? Huh? SATP condition of the it is standard ambient temperature pressure condition. Okay, what is the condition? If you have to assume if there is a concentration and temperature and pressure, general logic, if they are not giving, logically in question, if they are not giving anything, it means you have to take 1 molar of concentration, 298 Kelvin, What atmospheric pressure? 1 atmospheric pressure. This also can be written as 1 bar. In question, if nothing is given, you have to take this condition, SATP condition, that 1 mole of concentration is equal to 298 Kelvin temperature of 1 bar atmospheric pressure. Then you can use the formula and calculate it. Okay. So in main, if all the reactants and the products are present in the respective standard state, the corresponding EMF is known as standard EMF. Okay. Then standard EMF has a constant value for the given reaction. So constant value for the given reactions. Okay. Then you have calculating of EMF. So EMF vargu mustine. Next you have Shri and rest. Okay. So EMF vargu mustine. Shri and calculator. Okay. So how to there is a question you have to calculate EMF of cell, right? You have found. Calculate EMF of cell. How do you calculate it? Right? Yes. So in the we generally know in first year PUC based on thermodynamics chapter, that is E naught cell, right? E naught cell is equal to E cathode naught minus E anode. This we know. Correct. So what is E naught of cell? It is EMF of standard state, right? It is EMF of standard, and this is EC is standard reduction potential of cathode. So standard reduction potential of cathode. Okay. Then anode is standard reduction potential of anode. Okay. So this is reduction potential of cathode. This is your reduction potential of anode, and this is your standard electrode. Okay. So mainly to calculate the EMF of cell, we have to know the Nernst equation, right? One is Nernst equation. The Nernst equation derivation I'll teach you later. Okay. Then this EMF of cell, it can be given has two cases. One is case 1, case 2. If you remember this, it's enough. Okay. Don't want Nernst equation or nothing. Okay. So we have to remember case 1, if it is spontaneous, you have to check whether it is spontaneous. Second, you have to check it is non-spontaneous. If it is spontaneous, what happens? A reaction, it is positive. A reaction is positive. Correct. Then EMF must be what? EMF must be spontaneous. EMF must be spontaneous. Spontaneous anta ಹೇಳಿದ್ರೆ EMF ಪಾಸಿಟಿವ್ ಆಗಿದೆ ಅಂತ ಅರ್ಥ. ರಿಯಾಕ್ಷನ್ ಪಾಸಿಟಿವ್ ಆಗಿದೆ, EMF spontaneous ಆಗಿ ಪಾಸಿಟಿವ್ ಆಗಿದೆ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. This two hint if you remember enough. Okay, if it is non-spontaneous, a reaction is negative, then the EMF this if you remember enough. Okay. Okay, we saw 5 questions until now. Till what I have reached, that question I will discuss. Okay. A cell reaction would be spontaneous if delta G value of a reaction is dash. Option 0, positive, negative, can't be predicted. Tell me the answer. A cell reaction is spontaneous if a reaction is spontaneous. Delta G value of a reaction. Delta G.
No, delta will be positive for non-spontaneous.
This is for what? Spontaneous. Okay. It is negative. See, understand the question. A cell reaction, okay, a cell reaction is called spontaneous if the delta G value, not on EMF of cell. They are asking you what type of.
They mentioned delta G.
Delta G mention ಮಾಡಿದ್ದಾರೆ. ನಾನು ಇವಾಗ ಕ್ಲಾಸ್ ವರ್ಕು ಕಳಿಸ್ಲಿಕ್ಕೆ ಆಗ್ತಿಲ್ಲ ಯಾಕಂತ ಐ ಡೋಂಟ್ ನೋ. ಯಾವ್ದಾದ್ರು ಒಬ್ರು ಐ ಗಿವ್ ಯು ಕ್ಲಾಸ್ ವರ್ಕ್ ಪ್ಲೀಸ್ ಟೇಕ್ ಅಂಡ್ ಸೆಂಡ್ ಮೀ ಓನ್ಲಿ. ಐ ಡೋಂಟ್ ಹ್ಯಾವ್ ಸ್ಟೋರೇಜ್ ಇನ್ ಮೈ ಫೋನ್. ಸೀರಿಯಸ್ಲಿ ಇದು ಯಾ ಮಾಡ್ಕೋತೀರಾ? ಕೊಡ್ಲಾ ನಾನು? ಮಾಡ್ಕೊಡು. I don't know why I can't. Yesterday I took my phone to do. I took one photo. That's all. My phone got stuck. It didn't open also. At midnight, 1 o'clock it opened. Seriously. This is my 6 years phone. My 6-year phone. I didn't even change anything. It's like new phone. But only inside it is gone. Dead. I even not change the glass. It's like that. And when I was first PU, ಅವಾಗ ಕೊಟ್ಟಿದ್ದು ಫಸ್ಟ್ PU ಅಲ್ಲಿ ಇರುವಾಗ ಫಸ್ಟ್ ಗಿಫ್ಟ್ ಫ್ರಮ್ ಮೈ ಡ್ಯಾಡ್ ವಿತೌಟ್ ನೋಯಿಂಗ್. ಓಕೆ, ಇದಾಯ್ತಲ್ಲ. ಡೆಲ್ಟಾ ಜಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ಸೊ ಅವಾಗ ನೆಗೆಟಿವ್ ಬರೀತೀರಾ. ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಒನ್. ಓಕೆ, ವಿಚ್ ಆಫ್ ದ ಫಾಲೋಯಿಂಗ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಈಸ್ ಕರೆಕ್ಟ್? ವಿಚ್ ಆಫ್ ದ, this is asked in all the 4 paper, all the 4 NEET, CET, COMLEC, JEE, rest JAM also. Okay, which of the following statement is correct? Okay, one is first one. Let me write it newly because it is confusing. One is cathode is negative terminal in both galvanic and electrolytic cell. Is this correct? No, I told you that chart. So this is wrong. Okay, then anode is positive terminal in both galvanic and electrolytic. False. Then third, cathode and anode are negative. Cathode and anode are negative terminal in both electrolytic cell and galvanic cell. Remember, cathode and anode are negative terminal in both electrolytic and galvanic cell. Electrolytic cell ಅಲ್ಲಿ cathode ಏನಾಗಿತ್ತು? Cathode ನೆಗೆಟಿವ್ ಆಗಿತ್ತು ತಾನೆ. galvanic cell ನೆಗೆಟಿವ್ ಮತ್ತೆ ಇದರಲ್ಲಿ ಪಾಸಿಟಿವ್. ಸೊ ಡಿಫರೆನ್ಸ್ ನೋಡಿ, cathode and anode ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. Cathode and anode are negative terminal in electrolytic and galvanic cell. Then fourth option, cathode and anode are positive terminal in both electrolytic cell and galvanic cell. Which is correct? Fourth one is correct. Pakka a table ನೋಡ್ಕೊಂಡು ಹೇಳ್ತಿದ್ದೀರಾ? Because here they have given wrong. Because of that only this question is being mainly targeted. ನಾನು ನೋಡ್ಕೊತೀನಿ. In galvanic, what they have asked, anode and cathode, right? Anode and cathode.
In galvanic cell, anode will be positive. Cathode will be negative.
What they have asked first ಅಲ್ಲಿ electrolytic cell. Electrolytic cell ಅಲ್ಲಿ cathode ಏನಾಗಿದೆ? Positive. Then anode ಬಂದ್ಬಿಟ್ಟು galvanic cell ಅಲ್ಲಿ ಏನಾಗಿದೆ? Positive. So which is, this is correct or check that. Electrolytic cell ಅಲ್ಲಿ cathode negative ಆಗಿದೆಯಾ?
No.
ಇಲ್ಲ. Then galvanic cell ಅಲ್ಲಿ anode negative ಇದೆಯಾ?
No.
Anode is negative.
No, anode is positive. In galvanic cell.
In galvanic cell, anode is negatively charged.
Positively charged. Cathode is negatively charged. Galvanic cell, anode is positive, cathode is negative.
This is galvanic cell. ಇದು ನೆಗೆಟಿವ್, ಇದು ಪಾಸಿಟಿವ್. ಎಲೆಕ್ಟ್ರೋಲೈಟಿಕಲ್ ಪಾಸಿಟಿವ್ ನೆಗೆಟಿವ್. ನೀನು ಇದು ಉಲ್ಟಾ ಬರ್ಕೊಂಡಿದ್ಯಾ? ನಾನೇನಾ? ನಾನೇ ತಪ್ಪು, ಅದನ್ನ ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಹ್ಯಾವ್ ಯು ರಿಟರ್ನ್ ಎಕ್ಸಾಮ್? ಪ್ಲೀಸ್ ಚೆಕ್ ಇಟ್. Please check this. ಇದರಲ್ಲಿ ನಿಮಗೆ ಮೇನ್ ಟಾರ್ಗೆಟ್ ಕ್ವೆಶ್ಚನ್ ಇದೆ. 3A ಕರೆಕ್ಟ್. ಆಪ್ಷನ್ 3 ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಸಿ ಚೆಕ್ ಪ್ಲೀಸ್ ಚೆಕ್. Galvanic cell, anode and cathode. Galvanic cell ಅಲ್ಲಿ negative, this is positive. Okay, in electrolytic cell, anode is positive, this is negative. Please check. ಇದರಲ್ಲಿ ನಿಮಗೆ ಪಕ್ಕಾ ಕ್ವೆಶ್ಚನ್ಸ್ ಇದೆ, please check. Galvanic cell, anode is negative, cathode is positive. Electrolytic cell, anode is positive, cathode is negative. Correct ಇದೆಯಪ್ಪ? Shweta and what's your name? Abhishek. Yeah, Abhishek. Correct ಇದೆಯಾ? Okay, so ಈಗ ಹೇಳಿ ಇದರಲ್ಲಿ ಈ ಎರಡು ಆಪ್ಷನ್ ಅಲ್ಲಿ ಯಾವುದು ಕರೆಕ್ಟ್? Third. This is correct. Okay. ಇದು ಪಕ್ಕಾ ಕ್ವೆಶ್ಚನ್. Okay. Every year they are appearing it because it is very tricky, right? Positive and negative charge. Then third. Okay. Molten sodium chloride. Okay. Molten sodium chloride conducts electricity due to the presence of what? Due to the presence of what? First, free electron. Second, free ions. Third, free molecules. Fourth, atoms of sodium chloride. Tell me the option. Tell me which is correct. Molten sodium chloride conducts electricity due to the presence of what? See, in charge carrier there is two types, you know, free ions and free electrons. Now, what they have asked here, molten sodium chloride conducts electricity is due to what?
Electrons.
Electrons or ions?
Ions.
Electrons or ions? Conducting electricity ಹಾಕಬೇಕು ಅಂದ್ರೆ electrons response ಆಗುತ್ತಾ, ions response ಆಗುತ್ತಾ? Ions ಅಲ್ವಾ? You have to check this main word. ಇದರಲ್ಲಿ ಟ್ರಿಕ್ಕಿ. ಈ ಎರಡರಲ್ಲಿ ಯಾವುದು? ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಂತ ಖಂಡಿತ ಆಗಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ, ಆಟಮ್ಸ್ ಅಂತ ಆಗಕ್ಕಾಗಲ್ಲ. So you are getting cancelled this and that. Okay, among these two we have to check the answer. This main electricity, logically electricity ಆಗಬೇಕಂದ್ರೆ electrons or ions? Ions. So ions, this is the answer. Okay, ಕ್ವಶನ್ಸ್ ನಮಗೆ ಗೊತ್ತಿರುತ್ತೆ ಆನ್ಸರ್, ಈ ತರ ಕೊಟ್ಟಿರುವಾಗ ನಾವು ಮಿಸ್ ಮಾಡೋದು. ಓಕೆ, ದೆನ್ which of the following statement is correct about galvanic cell? So ಇದೇ ರೀತಿ electrolytic cell ಕೊಡ್ತಾರೆ. ಓಕೆ, first one, it converts electrical energy into chemical energy. Second, it converts metal from its free state to the combined state. Free state in the combined state. Third, it converts electrolyte into individual ions. Fourth, it converts chemical energy to electrical energy. So now tell me, which of the following statement is correct about galvanic cell? Galvanic cell, which of the following is correct? Chemical energy to electrical energy. Correct alva? Now the same option, question change agutte. Which of the following statement is incorrect about galvanic cell?
Electrical energy to chemical energy.
Okay, two types of question. Clear? Matte ide free state ions idadella illa. Okay, the two options are negligible. Okay, next, the function of a salt bridge is to. The function of a salt bridge is to first maintain electrical neutrality. Adena pakka. Second option, the correct time. See options nodi. Increases the cell potential at positive electrode, decreases the cell potential at negative electrode. Okay. Fourth, eliminate the impurities in electrolyte. Okay, which this is correct. The function of salt bridge is to maintain the electrical neutrality of both half cells. And one more thing, whatever you are seeing, options, ಯಾವುದೇ options ಕೊಟ್ಟಿದ್ರು ಈ options ಅದೇ ಲೆಸನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಓಕೆ, ಇದಕ್ಕೆ ಕ್ವಶನ್ ಹುಡುಕಿ. ಆಗಲ್ಲ, ಲೇಟ್ ಆಗೋಗುತ್ತೆ. ಸಿ ಇದೇ ತರ ಆಪ್ಷನ್ಸ್ ಹಿಂಗ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ಈ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಒಂದು ಕ್ವಶನ್ಸ್ ಫ್ರೇಮ್ ಮಾಡ್ತಾರೆ. ಓಕೆ, ಸೊ ಇನ್ಕ್ರೀಸಸ್ ಸೆಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಟ್ ಪಾಸಿಟಿವ್ ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ಇದರಲ್ಲಿ ನನಗೆ ಚಾನ್ಸಸ್ ಆಫ್ ಕ್ವಶನ್ ಇಸ್ ವೆದರ್ ಇಟ್ ಇಸ್ ಇನ್ ಎಲೆಕ್ಟ್ರೋಲಿಟಿಕ್ ಸೆಲ್ ಆರ್ ಗ್ಯಾಲ್ವಾನಿಕ್ ಸೆಲ್, ಅದು ಕೂಡ ಬರ್ಬಹುದು. ಐ ಡೋಂಟ್ ನೋ, ಅದು ಕೂಡ ಬರ್ಬಹುದು. ಕರೆಕ್ಟ್. ಸೊ ದಿಸ್ ಇಸ್ ದ ಮೇನ್ ಟಾರ್ಗೆಟ್ ಅವರಿಗೆ. ಆಪ್ಷನ್ಸ್ ಹೇಳ್ಕೊಡ್ತಾರೆ, ಆಪ್ಷನ್ಸ್ ಇಂದ ಕ್ವಶನ್ಸ್ ಹುಡುಕ್ತಾರೆ. ದೇ ವಿಲ್ ಸರ್ಚ್ ಬಿಕಾಸ್ ದೇ ಆರ್ ಸೈಕೋ ಆಗಿರ್ತಾರಲ್ಲ ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ, ಅವ್ರಿಗೆ ಹೀಗೆ ಮಾಡೋದು. ದಿಸ್ ಇಸ್ ದ ಟ್ರಿಕ್ ವಾಟ್ ದೇ ಯೂಸ್. ಓಕೆ, ದಿಸ್ ಇಂಟ್ ಐ ಕ್ಯಾನ್ ಗಿವ್. ಈಗ ನನಗೆ ಗೊತ್ತಿರೋದು ಅದಕ್ಕೆ ನಾನು ಹೇಳಿದೆ. ನೆಕ್ಸ್ಟ್, represent the cell from the following cell reaction. Okay, you have to represent the cell. H2 gas plus Cl2 gas give rise to 2H plus 2Cl minus. You have to represent the cell from the following cell reaction as this. Options ಕೊಟ್ಟಿರ್ತಾರೆ, ನಾನು ಹೇಳಿದ್ನಲ್ಲ ಆಪ್ಷನ್ಸ್ ಏನು ಕೊಟ್ಟಿರ್ತಾರೆ ಅಂತ. 1 2 3 4. ಸೊ ಇಲ್ಲಿ ಆಪ್ಷನ್ಸು PT H2 plus, okay, salt bridge Cl minus Cl2 PT. Yes. Okay. Then rest of the option H2 plus salt bridge Cl minus Cl2. That's all. Then here H2 plus not salt bridge Cl minus Cl2 platinum. Then fourth option similarly, here they'll change. Okay, now tell me what happens here. I told you H plus acts in the presence of which electrode? Inert gas electrode. ಅದನ್ನು ರಿಮೆಂಬರ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಚಿತ್ತು ಅಂತ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಎಲೆಕ್ಟ್ರೋಡ್. ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಅಲ್ಲಿ ಏನು ಯೂಸ್ ಮಾಡ್ಕೊಂಡ್ರಿ? ಪ್ಲಾಟಿನಮ್ ಅಥವಾ ಪೆಲೆಡಿಯಂ. ಐ ಟೋಲ್ಡ್ ಯು PD ಆರ್ ಗ್ರಫೀನ್ ಆರ್ ಕಾರ್ಬನ್, ರೈಟ್? ಹಾಂ, ಸೊ ಈಗೇನು ಯಾವ್ದು ಆಪ್ಷನ್ ಕರೆಕ್ಟ್ ಇದೆ? ಯಾವ್ದು ಆಪ್ಷನ್ ಕರೆಕ್ಟ್? This is first, this is second, this is correct. Yes, that is correct. Okay, because standard electrode platinum do. Okay, so platinum ಇಲ್ಲಿ ಇಟ್ಕೊಂಡು ಇಲ್ಲಿ ಆ್ಯನೋಡ್ ಇಲ್ಲಿ ಕ್ಯಾಥೋಡ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಸೊ ಅದಕ್ಕೆ ಪ್ಲಾಟಿನಮ್ ಇಲ್ಲಿಗೂ ರೆಸ್ಪಾನ್ಸ್ ಆಯಿತು, ಇಲ್ಲಿಗೂ ರೆಸ್ಪಾನ್ಸ್ ಆಯಿತು. ಅದಕ್ಕೆ ಇಲ್ಲಿ ಪ್ಲಾಟಿನಮ್, ಇಲ್ಲಿ ಪ್ಲಾಟಿನಮ್. ಅನಲೈಸ್, ಕ್ವಶನ್ಸ್ನ ಅನಲೈಸ್ ಮಾಡ್ಕೋಬೇಕು. ಹೀಗೇನೆ ಅನಲೈಸ್. ಮಧ್ಯದಲ್ಲಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿಗೂ ಹೋಗ್ತಾನೆ, ಅಲ್ಲಿಗೂ ಹೋಗ್ತಾನೆ ಅಂತ ಅರ್ಥ. ಸೊ ಅದನ್ನ ಇಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ. ಓಕೆ, then for the cell reaction, which is correct? Okay, CuS plus Cl2 give rise to Cu2 plus 2Cl minus. Now option CuS salt bridge Cu2 plus Cl minus Cl2 gas. Will nodi carbon solid. Okay, then second option Cu solid bridge Cl minus bridge Cl2 salt bridge Cu2 plus CuS. Third, CuS solid. Okay. Then Cu2 plus aqueous salt bridge Cl minus Cl2. Fourth option CuS Cu2 plus Cl2 Cl minus. Tell me what is happening in Cu? Take main reaction. Cu ಇಂದ Cu2 plus ಆಗ್ತಿದೆ ಏನಿದು? Cu ಇಂದ Cu2 plus ಆಗ್ತಿರೋದು ಏನು? Oxidation. Okay. Then Cl2 minus ಇಂದ 2Cl minus ಆಗ್ತಿದೆ ಏನಿದೆ? Reduction. Okay. Now tell me which of this option is there?
First one correct ಅಂತ ಹೇಳಿದ್ರಲ್ಲ ಮ್ಯಾಮ್ ನೀವು ಫಸ್ಟ್
option. ಓಕೆ, ಸೊ ಯಾಕೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಡು ಸಿ ನ ಕೊಟ್ಟಿದ್ದಾರೆ. ಓಕೆ, ನಮಗೆ ಕ್ವಿಕ್ಕಿಯಾಗಿ ದೇ ವಿಲ್ ಗಿವ್ ಯು ಡಯಾಗ್ರಾಮ್. ವಿ ಆರ್ ನಾಟ್ ಗಿವಿಂಗ್ ಯು ಡಯಾಗ್ರಾಮ್ ವಿಚ್ ಇಸ್ ಸಿಮಿಲರ್ ಟು ದಟ್. ಎಲೆಕ್ಟ್ರೋಡಲ್ಲಿ ಇನ್ನಟ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಹ್ಯಾಕ್ ಮಾಡಲೇಬೇಕು, ರೈಟ್? ವೆನ್ ಯು ಟೇಕ್ ದಿಸ್, ಇಸ್ ದಿಸ್ ಕರೆಕ್ಟ್? ಇದು ಬರುತ್ತಾ? ಬರಲ್ಲ ಅಲ್ವಾ? ಸೊ ಇದು ರಾಂಗ್. ಇದ್ರಲ್ಲಿ ನೋಡಿದ್ರೆ ಇದು ಇಲ್ಲಿ ಬರ್ಬೇಕು, ಇದು Cl2 ಎಕ್ಸಿಟ್ ಆಗುತ್ತಾ? ತಪ್ಪು. ಇದ್ರಲ್ಲಿ ನೋಡಿದ್ರೆ ಇಸ್ ಇಟ್ ಕರೆಕ್ಟ್? ಆಕ್ಚುಲಿ ಇಟ್ ಇಸ್ ನಾಟ್ ಕರೆಕ್ಟ್. ಅದಕ್ಕೆ ಇದು. ಸೊ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಡ್ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಪ್ಲಾಟಿನಮ್ ದೇ ಹ್ಯಾವ್ ಯೂಸ್ ಸಾರಿ ಇದು ಇಲ್ಲ, ಕಾಪರ್ ಸಾಲಿಡ್ ಇದೆ. Then similarly for the galvanic cell ಇದೇ ರೀತಿ ಇನ್ನೊಂದು ಕ್ವಶನ್ ಟ್ರಿಕ್ಕಿಯಾಗಿರೋದು. PT ಸಾಲಿಡ್, ಓಕೆ, ಅದನ್ನ ಕೊಟ್ಟು ಇನ್ನೊಂದು ಕೇಳ್ತಾರೆ ಅಷ್ಟೇ. Fe2, Fe3 ಪ್ಲಸ್ ಸಾಲ್ಟ್ ಬ್ರಿಡ್ಜ್ Fe2 ಪ್ಲಸ್ Fe. ಸೊ ವಿ ನೋ ಸಾಲ್ಟ್ ಬ್ರಿಡ್ಜ್ ಈ ಕಡೆ ಇರೋದೆಲ್ಲ ಕ್ಯಾಥೋಡ್, ಈ ಕಡೆ ಇರೋದೆಲ್ಲ. Okay, what are the options? See, for the galvanic cell, this cell reaction is given. Okay, is. For the galvanic cell, they are given this reaction is. Okay, option 3 Fe3 plus Fe give rise to 2 Fe3 plus. Second, 3 Fe2 plus give rise to Fe plus 2 Fe3 plus. Third, Fe plus 2 Fe3 plus give rise to 3 Fe2 plus. None of the above. Tell me. Galvanic cell dash and dash and other reaction ಕೊಟ್ಬಿಟ್ಟು chemical reaction is ಅಂತ ಕೊಟ್ಟು ಆಪ್ಷನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. So what is ಇದಕ್ಕೆ ನೀವು ಏನು ಮಾಡಬೇಕು? ನೆಟ್ ಸೆಲ್ ರಿಯಾಕ್ಷನ್ಸ್ ಕಂಡುಹಿಡಿಯಬೇಕು. ನೆಟ್ ಸೆಲ್ ರಿಯಾಕ್ಷನ್ಸ್ ಹೇಗೆ ಕಂಡುಹಿಡಿತೀರಾ? ಆ್ಯನೋಡಲ್ಲಿ ಏನಾಗ್ತಿದೆ, ಕ್ಯಾಥೋಡಲ್ಲಿ ಏನಾಗ್ತಿದೆ ಚೆಕ್ ಮಾಡಿ. ಆ್ಯನೋಡಲ್ಲಿ ಏನಾಗ್ತಿದೆ? ಆ್ಯನೋಡ್ ಅಂದರೆ ಯಾವುದು? Fe2 ಪ್ಲಸ್ ಇಂದ Fe3 ಪ್ಲಸ್ ಆಗ್ತಿರೋದು, ಕರೆಕ್ಟ್? ಆ್ಯನೋಡ್ Fe2 ಪ್ಲಸ್ ಇಂದ Fe3 ಪ್ಲಸ್ ಆಗ್ತಿರೋದು ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಡ್ತಿದೆ? ಕ್ಯಾಥೋಡಲ್ಲಿ ಏನಾಗ್ತಿದೆ? Fe2 ಪ್ಲಸ್ ಇಟ್ ಇಸ್ ಅಕ್ಸೆಪ್ಟಿಂಗ್ 2 electron, right, to become Fe ಅಷ್ಟೇ. Fe this one. Okay, so now this is anode and this is cathode. Is it correctly balanced? ಇಲ್ಲಿ 2 electron ಇದೆ, ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ. ಅದನ್ನ 2 electrons ಅದಕ್ಕೆ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತಲ್ವಾ? ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನೇ ಇಲ್ಲ, ಎಲ್ಲೂ ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಟ್ಟಿಲ್ಲ. ನಾನು ಅದನ್ನ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಬೇಕು. ಇಲ್ಲ, ಅದನ್ನ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಲಿಕ್ಕೆ ಏನು ಮಾಡಬೇಕು? ಫಸ್ಟ್ ಯು ಆರ್ ಟೇಕಿಂಗ್ Fe2 plus, okay, plus 2 electron is already there. You are taking that Fe, correct? ಇದಕ್ಕೆ ನೀವು ಆ್ಯಡ್ ಮಾಡೋದು ಇದು ಅಲ್ವಾ, Fe2 Fe3 ಪ್ಲಸ್ ಇ. ಇದನ್ನ 2 ಬರಬೇಕು ಅಂದರೆ ಏನು ಮಾಡಬೇಕು? ಓಲ್ಡ್ ರಿಯಾಕ್ಷನ್ಸ್ನ ಯು ಹ್ಯಾವ್ ಟು ಮಲ್ಟಿಪ್ಲೈ ವಿತ್ 2, ರೈಟ್? ವೆನ್ ಯು ಮಲ್ಟಿಪ್ಲೈ ವಿತ್ 2 ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಇಸ್ 2 Fe2 ಪ್ಲಸ್ ಗಿವ್ ರೈಸ್ ಟು 2 Fe3 ಪ್ಲಸ್ 2 ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ಆರೋ ಮಾರ್ಕ್ ಆಚೆ, ಆರೋ ಮಾರ್ಕ್ ಒಳಗೆ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತಾ? ಏನು ಬರುತ್ತೆ ಈಗ? 2 ಪ್ಲಸ್ 3 3 Fe2 ಪ್ಲಸ್ ಗಿವ್ ರೈಸ್ ಟು Fe. ಎಲ್ಲಿದೆ ನೋಡಿ? ಯಾವ ಆಪ್ಷನ್? ಇದು ಅನಲೈಸೇಷನ್. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಇದೆ ಅಪೋಸಿಟ್ ಆಗಿ ಕೊಟ್ಟಿರ್ತಾರೆ. ಈಗ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನೇ ಇಲ್ಲ, ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಹೋಗ್ಲೇಬೇಕು ಆಕ್ಸಿಡೇಷನ್ ಅಂಡ್ ರಿಡಕ್ಷನ್. ಈ ಥರ ರಿಯಾಕ್ಷನ್ಸ್ ಕೊಟ್ಟಾಗ ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ಆನೋಡ್ ಅಂಡ್ ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ಕ್ಯಾಥೋಡ್. ದೆನ್ ವಾಟ್ ಈಸ್ ಹ್ಯಾಪನಿಂಗ್? ಓಕೆ, ಅವಾಗ ಇಷ್ಟರಿಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಎಲೆಕ್ಟ್ರಾನ್ನ ತೆಗಿಯೋಕ್ಕಾಗುತ್ತೆ. ಅದು ನೋಡಿ ಆಪ್ಷನ್ಸ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ಫಾರ್ 2 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್. ಈಗ ನಾನು ಸಾಲ್ವ್ ಮಾಡಿಸ್ಕೊಂಡು 2 ಮಾರ್ಕ್ಸ್ 1 ಮಾರ್ಕ್ ಸಾಲ್ವ್ ಮಾಡಿ. ಸೊ ಅಂಡರ್ಸ್ಟುಡ್? ಇಲ್ಲಿವರೆಗೂ ಮಾಡಿರೋದ್ರಲ್ಲಿ ಏನಾಯಿತು? 2 ಮಾರ್ಕ್ಸ್ ಇಲ್ಲ ನೀಟಲ್ಲಿ. ಪಾರ್ಟ್ ಸಿ 2 ಮಾರ್ಕ್ಸ್ ಇದೆಯಲ್ಲ, ಪಾರ್ಟ್ ಎ ಪಾರ್ಟ್ ಬಿ ಅಲ್ಲ ಇದೆ ಅಲ್ಲ 2 ಮಾರ್ಕ್ಸ್.
Each question carries 4 marks.
4 ಮಾರ್ಕ್ಸ್ ಇದೆಯಾ? ಓಕೆ, ದೆನ್ 4 ಮಾರ್ಕ್ಸ್. ಇಲ್ಲ, ನಾನು ಬರೆಯುವಾಗಿತ್ತಲ್ಲ 3 year I wrote NEET exam. Frankly speaking, I wrote NEET exam. There was -2 or +2?
+4 -1.
ಓಕೆ, ಚೇಂಜ್ ಮಾಡ್ಬಿಟ್ಟಿದಾರಾ? ಇಲ್ಲ, ನಾನು ನೀಟ್ ಬರ್ದಿದ್ದೆ ಯಾವಾಗ ಅಂದರೆ 2017. 2017 ನನಗೆ +2 or -2? ನೆಗೆಟಿವ್ ಮಾರ್ಕ್ ವಾಸ್ -2. -2. ಅದಕ್ಕೆ ನನಗೆ ಮಾರ್ಕ್ಸ್ ರ್ಯಾಂಕಿಂಗ್ ಬಂದ್ಬಿಟ್ಟು 65 or 75 ಪ್ಲಸ್ ಬಂದ್ಬಿಟ್ಟು. ಕಾಸು ಎಲ್ಲಿಂದ ಹೋಗ್ಕೊಡ್ಲಿ? ಕಾಸು ಎಲ್ಲಿಂದ ತಂದೋಗ್ಕೊಡ್ಲಿ ನಾನು? ಅದಕ್ಕೆ ಬೇಡ ಅಂತ ಮೆಡಿಕಲ್. ಮೈ ಏಮ್ ವಾಸ್ ಟು ಬಿಕಮ್ ಡಾಕ್ಟರ್. Even you, I wish all the best, but please you have to work on it. ನನಗೆ ಕಾರ್ಡಿಯಾಲಜಿಸ್ಟ್ ಆಗಬೇಕಂತ. ಕಾರ್ಡಿಯಾಲಜಿಸ್ಟ್ ಆರ್ ಗೈನಕಾಲಜಿಸ್ಟ್, ಸೇಮ್ ಮೈ ಥಾಟ್ ವಾಸ್ ದಟ್. ಬಟ್ I don't know what happened. I came here. That was my main target. ನನಗೆ main cardiologist ಆಗಬೇಕಂತ. If I'm not getting that, then the second option was my gynecologist. That was my, I love this 2 subjects, cardiologist or gynecologist. Unfortunately, yellow. Okay, so till here I'll stop. Okay, so you have understood, right? Yes.